welcome. We're going to do a quick walkthrough. We're looking at 6.4, 6.5, 6.6. My apologies for the chatter in the background. I do have tutoring going on, and it's okay. I love you guys having these conversations. Just remember, whisper for me, please, as I work on these walkthrough for you. So last time you had notes for quadrilaterals, chapter 6. I'll include a card for you so that you can get to that link quickly. But these are the notes that we're talking about. We'll be using all of these different theorems and properties of the different quadrilaterals. And we're also going to be using the brand new theorems that are in the most recent upload, chapter 6 quadrilaterals, part 2. That's how you say 2 in French. 2. All right, let's look at 6.4. And we're just going to talk about the setup. What kinds of things you need to know in order to make this happen. So looking at the first question, it says we're going to be doing some algebra stuff. And we have this quadrilateral RSTU, and it tells us that it is a rectangle. So going to our notes, we know that we're going to be using this information about rectangles, the fact that all 4 of those angles are right angles. We're going to be using the fact that the diagonals are congruent to each other. And because rectangles are one of the types of parallelograms, we're going to be using all of the properties of parallelograms to make this happen. So lots of information to continue to review. Let's work on this setup. So the first setup says that if UZ is x plus 21, so they're giving me a measurement for this segment here, and then ZS is some other value, 3x minus 15. It's giving me this segment here. They want to know the full segment length of that diagonal. So let's look at our properties of rectangles first. Properties of rectangles says that it has 4 right angles and that the diagonals are congruent to each other. That the diagonals are congruent to each other, this diagonal and this diagonal, really doesn't help me too much when I'm trying to find something across just one diagonal. So I'm going to turn back a page and look at the properties of straight up parallelograms. And since I'm given information on diagonals, I really want to look at the property that deals with diagonals, which is the very bottom one. Diagonals bisect each other. Please recall what the word bisect means. Take a moment right now, flip back through your notes. I'll put a card on screen for you to a link for bisect. All right, now that you've had a chance to look that over, we'll have found out that bisect means that it cuts into 2 congruent pieces. So that means that this diagonal was bisected by this other diagonal, which means this diagonal, gentlemen, thank you. This diagonal is cut into 2 congruent pieces, so UZ is congruent to ZS. And that really becomes the first statement that I can make here. Now, by definition of congruence, I know that things that are congruent are the same size and the same shape, which means that because these 2 segments are congruent to each other, their measures are equal. So when I take away the little segment bar above the name, it goes from naming the segment to stating the measure of the segment. So the second line reads, the measure of UZ is equal to the measure of ZS. I'm putting the little squiggly bars between my steps to make it easier to read. Now I'm going to substitute what I know. Here's UZ, here's ZS. So substituting in for what I know, and my setup looks like this. Shh, gentlemen. I'll go ahead and do some algebra, and when I am done with that algebra, x will be some number. Now that's not my final answer, however, because I am asked to find the value of UZ, the measure of US, excuse me. I need to find the measure of US. But remember that US is that big diagonal, which comes from the measures of the 2 pieces, UZ plus ZS. And since I know what those measurements are right here, and now that I have found the value for x, I can substitute in the value that I found into each of those expressions, total it all up, and get my final answer. The same sort of thought process is going to go into finding each and every one of these. You have things from different diagonals being congruent or not, your information being given from different pieces of diagonals. You've got full diagonal here and a part of the diagonal that you're going to have to figure out. You're being given some information about angle measures, and so you'll probably need to look at the angle measure information on rectangles and parallelograms. All right, let's take a look at the next page. Next page, you're finding the measures of a bunch of angles. There's the graphic off to the right that you're going to need to look at. You're given the measure of one of those angles, and you have to calculate the rest. Again, make heavy use of your properties, both of parallelograms and of rectangles. The coordinate geometry one, you'll need to grab a sheet of graph paper. There's some available in room. If you don't have any, you can just do it on another sheet of paper. Mark which number it is that you're doing and start drawing. Use as much of this paper as you need. Now it's asking you to determine whether it's a rectangle or not. Once you've drawn it, it should be fairly clear to you, especially those of you who are really familiar with what rectangles look like, as to whether or not this thing is or not. But it's asking you to justify, which means you need to state why you said yes or no. And it really wants you to do it using the formula that they've given you. So in this case, they're asking you to justify that it is a rectangle using the slope formula. So a couple things that you need to recall, and this is from your notes. The first thing to recall is that rectangles have 90-degree angles. And those 90-degree angles happen between consecutive sides. The next thing to recall is what slope means for parallel lines. Excuse me, not parallel lines, but for lines intersecting at 90 degrees. When they're intersecting at 90 degrees, we call that perpendicular, and so you need to go back to look at slopes of lines, particularly of perpendicular lines, and you can find more information on that in Chapter 3, Lesson 3. There will be a link on screen for you to click. Gentlemen, that's 3. Bring that volume way down, please. Thank you. So go ahead and click the link on screen for Chapter 3, Lesson 3. That'll tell you a bit about slope. And then once you found out which sides are the consecutive ones, run your slope formula and see if it meets this criteria for perpendicular. I spelled perpendicular wrong. There it is. I sort of fixed it. It looks ugly, but that's okay. All right, next one is asking you to see if it's a rectangle and then verify using distance formula. Again, the next thing for you to recall is that all rectangles are parallelograms. And so using your properties of parallelograms, you need to figure out which one will distance formula be helpful for you to use. Once you've recalled which property of parallelogram you're going to be using, please recall what the distance formula is. Here it is written on screen. And if you need help with how to use it, I will encourage you to go back and look at Chapter 1, Lessons 2 and 3. Again, link on screen for that on how to use distance formula. Here's another one using slope formula, so please see question number 13. Last one is a landscaping problem. My recommendation for you on this one is take up the page to draw it one sentence at a time. You're being asked to determine if the gardener can say whether this plot is a rectangle. Please explain why you said that. Again, you're going to be using your definition and properties of rectangles, which means, can you figure out if there's some right angles going on? Yes or no. Can you see if diagonals are congruent? Yes or no. Can you hit any of the parallelogram properties? Yes or no. That is the walkthrough for 6.4. I'm going to take a break, and when we come back on a new video, we'll have 6.5. Thank you.